Okay, we're going to continue now with Crawford. The section that we just read was called The Psychic Appeal of Manual Work, and as we noted, it is typical of Crawford to try to praise one side of an issue by beginning with what is beautiful and wonderful about it, and then as he moves through, look to its opposite. So if he's praising manual work at the beginning, then he is denigrating college work, brain work, the ghostly labors as he moves through. That is his method, his use of rhetoric, if you like. Okay, so the second section, cognitive demands of manual work. So obviously he's going to be talking here about cognitive or brain demands of manual work, which is to say manual work is not something that is brainless. It is in fact something that requires intelligence. And he again cites a source, Mike Rose, the book called Mind at Work, and saying, and this is a pattern that he does too. At his beginnings, he tends to look for minute examples and build toward larger claims as he goes. A kind of what is called an inductive structure, making observation, observation, observation before coming to a conclusion. Okay, in the Mind at Work, Mike Rose provides cognitive biographies of several trades and depicts the learning process in a woodshop class. What's a cognitive biography? Cognitive brain, biography, the story of a person. So the story of a person's brain and a person who is in the trades. And this is proven in multiple places. I can even recall a psychology class where we watched a video about the scientists doing kind of an autopsy on two different people, and I think one had been in real estate or something like that, and the other one had been a carpenter, and they discovered when they sliced up the brain that the person in the manual trade actually had a great deal more development in his brain than the other person who worked in something that was not manual. So yes, the cognitive biography of several trades. Depicts the learning process in a woodshop class. So how does the brain work in a woodshop class? That is the subject of part of Mike Rose's book. He writes that our testaments to physical work are so often focused on the values such work exhibits, rather than on the thought it requires, right? And this is sort of true. We tend to focus on the object. Well, he said before, the good thing about that is you can point and say, I made this, and that is a source of pleasure and satisfaction. But when the world looks at a thing, they focus on just the thing and not the maker, and they don't think about it as having thought process behind it. It is subtle but pervasive omission. People don't give credit for the thought that goes into made things. It is as though in our cultural iconography we are given the muscled arm, the sleeve rolled tight against biceps. I find this a very interesting image because when I think of a muscled arm with the sleeve rolled tight against biceps, I think of the old posters of Rosie the Riveter, a woman's arm. Maybe that's not what he meant, though. But no thought behind the bright eye. No thought bright behind the eye. No image that links hand and brain, which is a really important subject that he's going to talk about later. He's making the case that hand and brain are united in manual work and that they work together, whereas certain processes in our culture have made those things separate and suggested that brain should be without hand and hand without brain. Skilled manual labor entails a systematic encounter with the material world, precisely the kind of encounter that gives rise to natural science. There he goes now. He's talking about the hard sciences. Natural science is based on observation and, of course, experience. From its earliest practice, craft knowledge has entailed knowledge of the ways of one's materials, which is to say you can't really very well sculpt something if you don't have a very deep understanding of clay and a whole lot of practice with it. Nor can you do carpentry or plumbing. You have to have experience with the materials, understand how to bend them when they'll break, how to manipulate them, how to make them do what you want. So knowledge of their nature acquired through disciplined perception and a systematic approach to problems. And in fact, in areas of well-developed craft, Technological developments typically preceded and gave rise to advances in scientific understanding, not vice versa. What he's talking about here is that in times past, the technological developments that we have, you know, the computer that I'm using right now and the speakers and microphones in it, those things happened on the basis of scientific understanding. They preceded it, whereas now things are a little bit flip-flopped and technological developments. Anyway, the steam engine is a good example. It was developed by mechanics who observed the relations between volume, pressure, and temperature, right, having to do with gas and water and heat. This at a time when the theoretical scientists were tied to the calorie theory of heat. Okay, so his example here is meant to prove that pure science by itself doesn't lead to conclusions. And rather that straight observation without making assumptions about it, straight observation does lead to the success of the steam engine. It was developed through a process of experimentation, not through theory, mathematics, suppositions. Then he quotes Aristotle to sort of come to a very similar conclusion. Aristotle says that the lack of experience diminishes their power of taking a comprehensive view of admitted facts. Aristotle, by the way, is a Greek philosopher who turned our attention to what is called empiricism, which is to say that the only way to know that something is true is by doing it over and over again and seeing if the outcome is always the same. The only way to know the world is to know it through our senses, what we can see, what we can smell, what we can taste, what we can feel. And if something isn't appealing to our senses in one way or another, perhaps it is a thing that does not really exist and therefore is not important. Certainly, if we want to build things, we need to have a pretty good understanding of weight and gravity and symmetry and balance and so forth. And these are things that we apprehend in the physical world with our hands and our eyes. So experience, right, with the senses is what is needed to take a comprehensive view of facts, right? We have to be attending. Hence, those who dwell in intimate association with nature and with its phenomena are more able to lay down principles, right? And that is how ideas develop and how science proceeds. It is through observation of phenomena, of what is happening in the world. While those whom devotion to abstract discussions has rendered unobservant of facts are ready to dogmatize on the basis of a few observations. This is the problem, Aristotle is saying, is the people who don't pay attention to facts, people who do not notice that certain causes always lead to certain conclusions, the people who rely upon their dogma to tell them what is true. This is going to lead to problems. To dogmatize, right, is to, without science, without facts, without true conclusions, just make decisions about how things ought to be done, or what is true, without using the power of observation. Another example, Vernier scale, machinists. Invented in 1631, a mechanical calculus that renders continuous measurement in a discrete digital approximation to 4 decimal places. Well, that is pretty impressive for 1631 now, isn't it? These inventions capture a reflective moment in which some skilled worker has made explicit the assumptions that are implicit in his manual skill. Okay, so once again, it's the observers, the workers, the people who are using their hands and see firsthand how something happens. These are the people who are able to make the machines of our world that work.